Well, looking at the three of them, Fabric is really designed as a software as a service. It's a tightly integrated UI. It's got Power BI built into it. It's got some low code, no code options, and it's ideal for really your end-to-end analytics. So if you're looking to get like, especially if you're looking at like a departmental type implementation where the people don't necessarily have a lot of infrastructure expertise, but they do know their data pretty well. Fabric's very well suited for that case where they're going to run it end to end, straight within that platform. You have a standard UI that covers the whole piece. When you get over into Synapse, this is where you're going to get much more control over things compared to Fabric, and it's still going to be focused primarily on SQL with some of the Spark for the data heavy lifting. It's much more flexible. You have much more control over some of the nodes and other pieces that you'll have to do there, but you'll have to have that expertise and set up each of those pieces individually. Now, Databricks is really where you're going to get, it's Spark centric. It's really focused on that piece and its ability to scale out. It doesn't necessarily scale up, it scales out instead. And so with Databricks, you get a lot of fine-grained control over everything. I mean, you actually have to go through all the configuration of all the different parts, but it can be really customized for scenarios where you need to bring in some open source pieces. Does require a lot of coding expertise to set up those environments. So you're kind of looking at different audiences for the different products is really kind of how I'd outline those three big differences between the systems. Definitely would lean more toward Fabric in this case. Like I said, the emphasis is really on the end-to-end analytics. So if that's really the target and you're focused on just the components that you need to get the data massaged and packaged up for delivering the way that you want it to, that would be the preference because you've got some low code options in data flows. You don't have to worry about managing the infrastructure yourself. It's all handled there. It's a capacity build model. And then it seamlessly integrates with Power BI. I mean, it's kind of all within the same environment. So this is really where you're looking at, if you're looking at an analyst-driven project from the perspective of getting the Power BI reports out, that's an ideal platform for that type of scenario. So Databricks is going to be the clear choice, especially if you start measuring your data in like many terabytes, or even if you start hitting petabytes of data. Databricks is very scalable. I mean, it's very flexible as far as the platform goes. The ability to do a lot of heavy manipulations of the data, or if you've got really high machine learning type operations that you're doing within that space. Its performance scales a little better than either Synapse or Fabric as far as your ability to tune for the load that you're bringing in. So if you have fairly consistent loads and you can tune the clusters that you're assigning to those loads, Databricks is really going to be your performance choice there. Also, with regard to this, I mean, like we've mentioned before, you do have to have, there's a high code content that you have to have skills to be able to handle that. And if you do have to deal with multi-cloud, Databricks is really the only one of the three that you can deal with as far as being able to process on those. Now, if you're dealing with Fabric or Synapse, you can pull from other platforms, but it doesn't actually function in those spaces. So a true multi-platform would be something Databricks would be useful for. A unified platform, especially if you're looking at somebody that, say, for instance, has a lot of Power BI investment already. So they've got some Power BI reports, but it's mostly analyst driven. That's a really good scenario to expand and pull some of the data engineering aspects out of the work that you do strictly within Power BI. So it allows you to kind of pull that apart, scale that out separately, and pull that burden off of the Power BI modeling directly. That's a really good case for like migrating from existing. If you're looking at kind of greenfield, brand new stuff. When you're choosing Fabric, again, it's a software as a service. It's not a platform that you have to maintain. That's a really big bonus when it comes to a lot of organizations where they maybe don't have a large Azure footprint already. So with those cases, we're really looking at, it's flexible, pay as you go. It vertically scales by SKU. When you're pulling in the compute piece, compute and storage are both separate in those in Fabric. So you pay for your storage and you pay for your compute, and it's shared. So with the lower there's a lower bar of entry to get into a Fabric implementation, and you can get around to getting through your data processing into results a lot quicker within the context of a Fabric implementation. When you're looking at the three platforms with regard to the maintainability, when you're looking at Fabric, you don't have the infrastructure to have to maintain. So there's it's centralized as far as updates are control. You don't have to go through those processes to update that. So from a platform, you don't have to maintain as much there. Where you kind of the middle ground is in Synapse, where you've got some controls over some of those pieces, but a lot of it is still kind of maintained by the platform. And then in Databricks, it's got that ability to scale horizontally as well as having that fine-grained control. You need to have the governance in place to manage that. If nodes they can utilize a lot of your capacity and get billed for. So Databricks kind of has a similar billing model as Fabric does with regard to your purchasing capacity to scale there. And if that auto scales up, that can shoot through a lot quickly if some of your nodes. So you have to really kind of monitor those, and the governance around those is something that you have to really be mindful of longer term. Fabric and Databricks both use like the Delta Parquet format. So there you're dealing with kind of an open source format. In Synapse, you're kind of not as flexible there. It doesn't standardize on anything in particular, where long term, if you're looking at Fabric or Databricks, file format is something that's very advantageous for them. When you're looking at Fabric, it's like very ideal for somebody that's basically started the analytics journey from Power BI. They've got some reports in there. They're doing all their data integration and cleansing and everything in Power BI. That's a natural progression to go into Fabric to be able to extend some of those capabilities using a very similar skill set to what you've already developed within Power BI. That's a very good fit for that platform. When you're looking at Synapse, really, this is more of your classic data warehouse type scenario. It's very geared toward that. It uses a very similar skill set, and it can handle very heavy SQL workloads. So when you take that into consideration, that's something that Synapse is very powerful with. Now, when you look at Databricks, its ideal case is processing lots of data, large scale ETL processes with a lot of transforms. You're looking at the leveraging heavily that Spark notebook and that cluster scalability. Machine learning and streaming are very effective within that space. The things that you would consider when you're looking at these different platforms are, what is your workload type? What is it that you want to be able to ingest? Are you focused on the BI? Are you focused on the machine learning? Are you very high ETL intensive? Is there a lot of transformation and stuff that you need to do, or a lot of data, or a little bit of data? So that workload type is really going to be one of the primary things I'd consider. Additionally, we've mentioned it a little bit before, but the team skills as well. It's like what skills does the team already have, and what type of a learning curve would it be for them to leverage one of these different platforms, or the technologies involved with those platforms. And along with the workload type is like, how scalable does it need to be? Do you foresee that the data is already very large and you need to be able to scale that out immediately? Or is it something where it's like, hey, we're doing something that's a pilot now and we're going to grow very rapidly Or is it going to be something that grows very slowly and you're pretty much at this kind of the state that it is now, which is minor growth? And then what type of ecosystem? Both Synapse and Fabric are kind of locked into Microsoft, for instance, where Databricks is on a lot of the different platforms, your AWS, your Google. It's available there as well. Which kind of cost model that you're after? So with Fabric and with you're looking at a capacity model. It's shared across everything. When you're looking at Synapse, it's pay as you go with the different components that you have as you go through that. And then Databricks again is kind of a usage based as well. So that may be something that you consider. Also look at kind of the governance of the platform itself, and really you're looking at Fabric is centralized, Synapse is fairly modular, and then Databricks is relatively open. And then really it's like, hey, there's also the vendor. We kind of mentioned it with which ecosystem you're in, but the vendor is like, hey, Fabric is future focused. It's kind of geared for, i.e., the next generation of analytics, where Synapse is a mature platform and Databricks is open and evolving. So those are some considerations that a company might have when they're looking at this.